Diode equivalent circuits. So today in this session we will study about the diode equivalent circuits. Diode approximation describes the behavior of diode circuit which is useful in the analysis of the device. So there are different types of diode approximation. So those three different types of diode approximation are ideal diode, practical diode and piecewise linear characteristics. So in the last sem the question was on this: explain the diode approximation in detail, or explain the different types of diode approximation. So let us discuss the answer for this as well as what it is. So the first approximation is ideal diode. The first approximation you can see here, this represents the diode as being ideal. The first approximation ignores the leakage current, barrier potential and bulk resistance. When an ideal diode is forward biased, the model is a closed switch. When the ideal diode is reverse bias, model is a open switch. You can see the diagram and graph of this ideal diode. You can see if when it is forward bias it is a closed switch, when it is reverse bias it is a open switch. You can see here, this is your ideal diode. The graph you can see it will be a linear straight line. Okay, next we shall study what do you mean by practical diode. So practical diode, it is a model assumes that no diode current flow until the forward bias crosses the diode reaches 0.7 volts. Okay, so this model ignores the extra shape of knee. You know how the diode was conducting in the silicon channel. It used to conduct in this way, extra shape of knee. Okay, this exactly it ignores that. You will get a straight line once it reaches a conducting point. You can see here it is also called as real diode. So here see it will be a the graph you can see here, once it reaches a 0.7 it starts conducting. Once it reaches 0.3, germanium 0.3, silicon 0.7. So that is what. So coming into a third approximation, it is a piecewise linear characteristics. So here when the forward characteristics of diode is not available, the straight line diode approximation called as piecewise linear characteristics may be employed. To construct the piecewise linear characteristics is first mark on the horizontal axis and start VF. A straight line is drawn with the slope equal to diode dynamic resistance. So you can see the diagram here. This is what the graph of the piecewise linear characteristics. Okay, next we shall discuss what do you mean by DC load line analysis. When the precise level of the diode current and voltage must be calculated, a graphical analysis term as DC load line analysis is employed. You can see the diagram of this. So there is a voltage which is connected to a resistor R and then to a diode. So current flows in this way. Okay, the current which is flowing here is IF. The current across the resistor R is given by IF into R1. Here diode, the voltage across the diode is given as VF. So plotting the DC load line on the diode characteristics, you can see here, this is a DC load line. This is a Q point. Okay, this is a diode characteristics. The plot is versus voltage versus current. So what do you mean by DC load line? DC load line is a straight line that illustrates all DC conditions that could exist within the circuit. DC load line can be constructed by plotting two corresponding current and voltage point and then drawing a straight line through them. To determine 2 points on the load line, an equation relating voltage, current and resistance is first derived for the circuit. Here, when we apply E is equal to IF into R1 plus VF. So what do you mean by Q point? Q point is also called as SJBIT point. Always the relationship between the diode forward voltage and the current in the circuit is defined by the device characteristics. Q point is only one point on the DC load line where the diode voltage current are compatible with the current circuit condition where the load line intersect the characteristics. So you can see this is a Q point. So what we discussed in this session is, we discussed what are the diode approximation. We studied about the 3 types of diode approximation. So that is a question which you do get in the exam, and then you need to know what do you mean by DC load line. Plot a DC load line. They might ask you plot a DC load line and explain the Q point. So these are the 2 questions in this session we studied. We shall look into few more in the next class. Thank you. So these are the few applications of diode. You can just look into it. By this we will end the session. Thank you. Next we shall discuss about the introduction to xenodiode. So it is a heavily doped semiconductor diode which is designed to operate in reverse direction and is known as Zener diode. In other words, diode which is specially designed for optimizing the breakdown region is known as Zener diode. So this is a symbolic representation of Zener diode. So anode and cathode. Anode means positive, cathode means negative. So coming into a working of Zener diode, when no biasing is applied across the Zener diode, the electrons remains in the valence band of the p-type material and no current flow through the diode. When the reverse bias is applied across the diode and the supply voltage is equal to the Zener voltage, then it starts conducting in the reverse bias. When a junction diode is reverse biased, normally only a very small reverse saturation current flows. So when the Zener diode is connected in the forward bias, it behaves like an ordinary diode. But when the diode is reverse, when it is reverse, voltage is applied across it, it rises beyond the predetermined rating and Zener breakdown occurs in the diode. So forward characteristics of Zener diode, again it works like a similar ordinary diode. Here Vz is given by Zener breakdown voltage, IZT is given by test current for measuring Vz. IZK is given by reverse current near the knee of the characteristics, the minimum reverse current to sustain the breakdown. IZM, it is a maximum Zener current limited by the maximum power dissipation. So next we shall discuss what do you mean by Zener breakdown and what are the types of Zener breakdown. So when junction is reverse bias, normally only very small reverse saturation current flows. IS on the reverse characteristics, when the reverse voltage is sufficiently increased, the junction breakdown and a large reverse current flows. If the reverse current is limited by means of a suitable series resistor, the power dissipation in the junction can be kept to a level that will not destroy the device. In this case, Zener diode characteristics may be operated continuously in Zener breakdown. The reverse current returns to its normal level when the voltage is reduced below the reverse breakdown level. So, with a very narrow depletion region, the electric field strength produced by a reverse bias voltage can be very high. The high intensity electric field causes the electron to break away from their atom, thus converting the depletion region from the insulating material into a conductor. This ionization by electric field is also called as Zener breakdown, and it usually occurs with reverse bias voltage which is less than 5 volt. This is the characteristics and parameters of the Zener diode. VZ, Zener breakdown voltage, IZT, test current for measuring VZ, IZK, reverse current near the knee of the characteristics, and minimum reverse current to sustain the breakdown, IZM, maximum Zener current limited by the maximum power dissipation. So you can see here in the forward bias it works like a normal. Yes, in the last slide we had studied about the Zener diode introduction. So breakdown also we studied about the breakdown. So there was a question which was asked in the previous year paper, that explain the Zener breakdown. Okay, there are two types of Zener breakdown. We shall discuss this. So what are the two types of Zener breakdown? So there are two mechanisms that causes a breakdown. So one is, there are two mechanisms that can cause the breakdown in the reverse bias PN junction. With a very narrow depletion region, the electric field produced by the reverse voltage can be very high. The high intensity electric field causes electron to break away from their atom, that converting the depletion region from an insulating material into a conductor. This is ionization by electric field and also called as Zener breakdown, and it is usually occurred with the reverse bias voltage which is less than 5 volts. Okay, this is about the Zener breakdown. So next, in the case where the depletion is too wide, the depletion region is too wide for Zener breakdown. The electron in the reverse saturation current can be given sufficient energy to cause other electron to break away when they strike an atom within the depletion region. This is termed as ionization by collision. The electron released in this way collide with other atom to produce more free electrons in an avalanche effect. This is called as avalanche breakdown. So avalanche breakdown is normally produced by reverse voltage which is above 5 volts. So things to remember here, there are two different types of breakdown. What are the two? Zener and avalanche. So in the Zener, the breakdown occurs less than 5 volts. Here in the avalanche, it exists above 5 volts. Okay. These are the two breakdowns which occurs in the Zener diode. Coming equivalent circuit of a Zener diode. So this is how you can represent the equivalent DC equivalent circuit of a Zener diode, and this is a AC equivalent of a diode. Okay, DC equivalent for the Zener diode is simply a voltage cell with the voltage VZ. This is the complete equivalent circuit for device for all DC calculation. For the AC, for the AC equivalent circuit, the dynamic impedance is included in the series with the voltage cell. The AC equivalent circuit is used in situation where the Zener current is varied by small amounts. It must be understood that these equivalent circuits apply only when the Zener diode is maintained in reverse breakdown. If the device becomes forward biased, then the equivalent circuit for forward bias diode must be used. By this, we end the Zener diode topic.